My name is Dr. Scott Gerard, and I'd like to talk to you today about artificial intelligence of things for a smart and sustainable future. So, what do we mean by sustainability? And in particular, what do I mean during this presentation about sustainability? The definition I'm going to use is we're looking for economic, environmental, and social benefits, sometimes called profits, planet, and people. But, generally, we're trying to reduce bad things like waste, time, electricity, resources, and costs. And we're also trying to enhance good things like privacy and explainability and fairness. So that's kind of a general picture of what we're trying to talk about here. Now, if we were talking about precision agriculture, and this presentation isn't about that, but if we were, what we would be talking about is, using fewer chemicals, less runoff, less environmental damage. If instead we were talking about the energy industry, we'd be talking about how could we use less fuel and make less emissions and maybe do some more CO2 recapture kind of things. And if we were in chip manufacturing, we'd probably be talking about how can we use less exotic chemicals, less toxic chemicals, more renewable chemicals, that kind of thing. But we're not doing any of those. What we're doing here today is talking about artificial intelligence and how can we make artificial intelligence more sustainable, particularly in the context of Internet of Things. And what that's going to mean for us is how can we reduce downtime? How can we use less electricity? How can we do better forecasting? And basically make our systems more trustworthy. So, if your job is to try to help your company become more sustainable, in regards to AI and AIoT, I'm going to try to give you some thoughts about how you can make some interesting goals around that for AI, which doesn't involve fewer chemicals and all the other stuff. So, it's a little bit different view on sustainability than some other areas are. I think one of the most interesting areas is we could be more sustainable if we could do better forecasting. And that's really going to provide an economic sustainability benefit. So the goal would be we don't want to over or under, have availability. We're trying to smooth out the demand, and therefore that will allow us to smooth out the production, and that will make things better. It will make us more economically profitable, more economically sustainable. What areas can we use better forecasting in? Well, any place where we've got clients making demands, right? So, how much product should I producing? How much power should I be generating? How much heating and cooling in a building should I be generating? What kind of lighting do I have to have? I don't want to be lighting rooms that don't have anybody in them. So if I can better forecast the demand, I can save some energy there. What AI approaches would we use to do that? Well, we could use classical time series forecasting. We find that we use more energy on the weekdays, not the weekends, that sort of thing. You may have some client or customer specific analyses that you can do to help you do better forecasting. And of course, dynamic pricing is one way to kind of influence how that forecasting would go. So better forecasting will give us some economic sustainability benefits. Related to that, but different, is maybe we could make better offerings. If we could design better offerings for our clients, that will mean we have more personalized offerings, more focused on the client. That means we'll have a lot less waste, we'll use less memory, we might use less communication resources and backup resources. We're just going to be more efficient and more bang for the buck, and we're going to have happier clients and customers as a result. So this one is really looking at environmental and social benefits. It applies to basically all AI infused products here because we want to skinny down the products to only put in what the client actually wants and what the client actually needs. How can we do this? Well, we need to really better understand what our clients' needs and wants are. But it also means we need to have more personalized builds. We need to have the infrastructure to do that, to better build it and do better deployments. But better offerings is another way to improve sustainability. Another one that is very common here is let's do better anomaly detection. we're talking about economic benefits and environmental benefits. We want to predict when a piece of equipment is in trouble and therefore may go offline. And in trouble is what the anomaly detection does. And if we detect an anomalies, then we want to go do some predictive maintenance. We want to send somebody out to really understand exactly what's going on and exactly what needs to be fixed. But how is this going to help us? Well, we're going to reduce unplanned downtime. Things aren't going to break in the middle of the night and we have to scramble people. When things break, they often do damage, right? So we're trying to, if we can catch it before it breaks, we can prevent some of that equipment damage. We might be able to diagnose some failures in real time because we have enough data to detect the anomalies. And basically, we're trying to maximize the life of our equipment, which is clearly an economic benefit, but it also is an environmental benefit because we don't have to build another machine and take all of the resources it takes to build that. Where can we do anomaly detection? Basically, anywhere you've got equipment. So, the energy industry, the manufacturing, construction, banking, all kinds of industries have equipment that if we can detect those anomalies, that would be a good thing. What do we want to do? Well, we first, of course, want to focus on the most critical and the most expensive pieces of equipment. That's where the biggest bang for the buck is. Now, there's two ways to do anomaly detection. One of them is model based. So this is the idea where you've got a model of the system typically based on some kind of physics equations, differential equations, whatever. And this is basically leading us into this whole idea of digital twins. And if the digital twin, if its prediction about what should be happening doesn't match what we're seeing in the real world, then that's a good indication that we may have an anomaly. But if we don't have those models, there's another way to do it, and that's a database. So we can watch a piece of equipment for a period of time and then build some deep neural networks that learn what is typical for that piece of equipment. And then that if we get into atypical areas, then that's a case where we probably have another anomaly. So we're talking deep neural networks here. Autoencoders are very common for this. There's also Bayesian networks that we could be doing. Those are the sorts of things that we can do there. This is a really interesting one. If we can make our machine learning models more efficient, in other words, fewer neurons, fewer calculations, smaller, that's the idea here. We can save energy, which is clearly an environmental benefit. Now, a lot of people have been trying to move to the cloud, but the cloud prices are going up. I'll show you a little bit of this here in a second. And some people are trying to move their models off the cloud into the edge. And in some cases, they can maybe even move some of those models down into microcontrollers, so very small pieces of hardware. Basically, any ML model can probably be made somewhat more efficient by some careful tuning or some various techniques. And what are we doing here? In large measure, what we're doing is we're saving electricity. And why is that important? Well, in a data center, a classic typical data center, over half of the electrical consumption of the data center is cooling. Those processors generate a lot of heat, and you have to spend a lot of electricity to cool them down to where they don't overheat. So if we can get rid of the cooling, we're basically halfway there anyway. So let's talk about ChatGPT in particular. Now, the numbers I'm going to show you here, these are estimates. The actual numbers have not been made public, but these seem like a pretty reasonable set of estimates. There's two real processes that go on with a model like ChatGPT. One of them is the training. There's a lot of people who've talked about it takes a lot of compute power to train some of these very large models. How much? Estimates are 1.3 gigawatt hours. How much is that? That's about how much 130 US homes use annually. So each time we train it, that's how much energy we're going to burn. Now, we're only going to do that once or a small number of times, but it's a big cost, but it's not going to add up it's not going to be repeated frequently. The other operation we do a lot more times, and that's to run a query against the trained model. How much energy does that take? Somewhere estimates are between 1.7 and 2.6 watt hours. How much is that? I want you to imagine that you've got a switch on your desk, and that's how you can control where the electricity is going. And you can flip it one way, and it runs a light bulb, and you can switch it the other way, and it runs a Chat GPT query. So if you've got that hooked up to a 150-watt incandescent bulb, a typical query means you're going to be in the dark for 2/3 to 1 minute. Not a lot of time, but not insignificant either. However, if you've already made the switch to LED lightings, those are like 14 watts. And so now for each query, you're going to sit in the dark for 7 to 11 minutes. That's kind of an idea for how much electricity these various large models are taking. Now, of course, the traditional models aren't going to spend near that kind of time, but this is the upper end as it is right now. And people are going crazy on generative AI. It's a cool technology. By 2027, I've seen estimates that the entire AI sector, so all of the models, all of the machine learning that's being done on the planet, will consume somewhere between 85 and 134 terawatt hours annually. So this is an ongoing budget where we're burning a lot of electricity. How much is that? It's about half of the global electrical consumption, one half of 1%. Um, that's a lot of electricity. So maybe we really do need to focus on some more efficient models here. How can we make the models more efficient? One way to do it is if we take the compute devices out of the cloud where we have to do all the cooling and distribute them physically throughout the environment. And if they're sitting where they can kind of cool naturally, just in their natural environment, well, like I said, we've gotten rid of about half of the electrical costs of it. And with IoT, that's what we want to do. We want to move processors away from the central thing out towards the edge or the far edge. There's also some really cool techniques where we can build smaller ML models. We take one model that we have, and there are some techniques where they can reduce the size of that model, compress it down a little bit, and keep either the same accuracy or maybe a little less accuracy, but much more reduced. TinyML is one technique that you can use to do that. The other one is model quantization. There's a lot of variations of it. One of them is instead of doing all these floating point calculations, which takes a lot of CPU power, we can convert many of them to integers and use integer arithmetic rather than floating point arithmetic. And we can do some savings there. So that's another way that we can get some environmental benefits for AI. We've talked a lot about environmental and economic benefits. Let's focus now on some social benefits, particularly. This is under a topic that I refer to as trustworthy AI. If you've heard responsible AI, it's essentially the same kind of a term. I view it as having a number of pillars in it, and I want to talk to you about three of those pillars, three things that make an AI trustworthy. The first one here is privacy. So we're talking social goals here. And we really want to enable people to own and control their own data. What is this applicable for? Basically every kind of AI and ML you can think of. Often we focus on people-related data. I don't want personal data to be made publicly available. I want to keep it private. But there's also non-people related data that you'll also probably want to keep private as well. But it basically applies to all kinds of machine learning models. There's a number of things that are underway that I think are going to help that. One of them is the W3C committee. That's the international committee. They've got a data privacy vocabularies and controls work that's going on. I think that's very interesting. That could be helpful. The EU they passed the GDPR Act a number of years ago, and just in the last month or two, they passed the AI Act. And that is making some of the privacy controls not good ideas. they are laws with requirements and fines and potential jail time related to them. So privacy is beginning to take, a really important element of all this, that you have to protect the privacy of data. I talked to a colleague a couple of months ago, and he turned me on to this idea called self-sovereign identity. What a lot of people do today is they'll go out to Google and they'll set up a Google account, and Google has their user ID, Google controls their password, and they use that Google account to log into a lot of other things, some of them Google applications and some of them not. Facebook does a very similar kind of a thing. That's a federated identity, and it's nice as far as it goes, but Google and Facebook are at the center of that, and they have a lot to say about what's going on. If you don't like that idea, this idea of self-sovereign identity is, I am myself, I am sovereign unto myself, I control my own identity, I create it, I own it, I control it, and no one else gets to have that kind of control over it. I think self sovereign identity is a really interesting idea that I'm hoping a lot more people will tap into. The next trustworthy AI pillar is explainability. And this is again for social benefits. It's really great and really important that our AI models are accurate. But in many cases, that's not sufficient. We need more. We need to not only know what the model predicted, but why did it predict that thing? And there's two kind of cases here that you might think about this. One is if you're a data scientist or a product manager, you want to kind of look overall, what how can I explain what this model is doing in general at the high level, at the global levels? What factors are really the most important for generating the model outputs and which ones aren't? But if you're an individual, let's say we're doing a loan application AI, Alice wants to know why she was refused a loan, not why everybody else did or didn't get one. She wants to know why she didn't get a loan. And she also wants to know, well, what can she change to improve her chances of getting a loan, right? So we can either do it this global overall level or an individual level. And the explainability depends on who we're talking to. So there isn't one explainability. There's an explainability for the different roles within the application. And this applies to all kinds of AI systems. There's two ways to really approach this. One of them is model specific. Some AI models, let's just think about decision trees here for a minute. They're just kind of naturally explainable. As long as there aren't too many nodes in the tree, we can follow through the tree and figure out how Alice, went down the tree and the fact that she ended up at a rejection. Or we can say, well, if she'd taken a different path at this node internally, she might have gotten over to where she could have been accepted. So that's the difference she needs to make. Some models are just kind of inherently explainable, but some models are not. Kind of the classic, extremely unexplainable models would be the neural networks. But fortunately, there are some black box explainability models that don't really care what the model is. They just look at lots of different variations about how the model works, and they can help explain which factors are important, why certain people might have been refused loans. They're not quite as precise as the model specific, but they're still pretty good, and they're definitely worth investigating if that's what your model requires. The last of these trustworthy AI pillars is fairness. Again, this is a social sustainability benefit. And the goal is to promote fairness. And I think identically that means to reduce bias. I use fairness and bias as the opposite sides of the same coin. And what we really want to do here is we just want to treat all groups equally. And particularly with some of the EU regulations and many other uh, groups are also promoting their own regulations. We want to comply with those regulations. And that means we're going to have to understand to what degree our algorithms are fair or not. Typically, in this case, we're talking about people-centric ideas, right? Nobody really cares whether we treat bulls and cows the same way or whether we treat roosters and hens the same way. We don't want to care about that. but we do care if we're treating men and women the same, or whites and blacks or other races the same. So this is definitely has a people-centric focus on it. And three of kind of the classic cases are sentencing guidelines. Some of you may have remembered the ProPublica um, discussions a number of years ago, where there were serious questions about whether it was fair in terms of sentencing guidelines for different races. Facial recognition came up a few years later that most of the facial recognition software is doing much better on light toned skins versus darker toned skins. And there was a lot of consternation about that for facial recognition AI algorithms. And people are having to go back and fix some of that stuff up. Employment decisions, right? Are we hiring whites and blacks, approximately equally? Are we hiring men and women approximately equally? Those are very important topics. So how do you go about doing this? Well, what you're basically going to have to do during the development phase is you want to compare the results for protected groups versus unprotected groups. And if they're basically the same, you're okay. If they're out of whack, you're not. One thing I want to dispel here is this idea of fairness through unawareness. A lot of people think that, I've got this data set and all I have to do is delete the sex column and the race column, and now my machine learning program can't figure out what's going on. So it has to be fair. Fairness through unawareness just flat out does not work. And it doesn't work because there are things called proxy variables. A classic proxy variable for income is zip code. Some zip codes are historically poorer people, and some zip codes are historically richer people. So if you leave the zip code in, you're still letting the AI model figure out that if income is important, that it will find that out. There are a lot of other cases as well. The one that I remember is that some company, I think it was an airline, you would log on and say, I want a flight from point A to point B, what's it going to cost? And they would look at the browser that you're using. If your browser was a Macintosh browser, they would quote you a higher price than if you were on a Windows browser, because they figured that if you had enough money to buy a Macintosh, that you had more disposable income and they could get more money out of you. So that's a very subtle proxy variable that just shows that fairness through unawareness does not work. Now, this is a really cool topic, and you say, well, I have to figure out what my metrics are for fairness, and I will optimize for that, and that's a good idea. The problem is there's a lot of metrics. There's over 20 metrics, and you can't satisfy all of them simultaneously. They measure subtly different things, and you need to pick the metric that's appropriate for your problem. But that's a very important topic as well. Fairness, this privacy, explainability, and fairness have been getting a lot more attention in the last few years, which they need to get a lot more. But we're making progress on those fronts. The last thing I want to talk about real quickly is I've always kind of thought of AI and AIoT use cases into kind of three big buckets. The first bucket is here on the left, and it's efficiency. And the idea is there's something that you're already doing today, but you want to do it better. And better could mean a lot of things. It could mean faster, cheaper, simpler, more reliable, whatever. But you're doing something today, but you just want to do it better. I think most of the cases that we're going to talk about fall into this efficiency bucket, and it's a great thing to work on. Sometimes, however, you want to do something new. That's the innovation bucket here in the middle. You want to create a new ecosystem. You want to enter a new market, a new business, a new service, whatever it is. You want to do something that you haven't done before. AI can help there as well, but it kind of has a different feel, and you have to approach it a little bit differently. That's also pretty common, not quite as common as the efficiency, but it's still pretty popular. The last one here is kind of a sleeper case. It's not done very often. I think you'll understand it when I explain it here. But we want to use the machine learning algorithms to influence our clients' behavior, not our behavior, but our clients' behavior. Classic case, auto insurance company. They want to put a little box on your car and it measures Are you accelerating hard? Are you braking hard? Are you speeding over the speed limit? If you don't do those things, we're going to give you a discount on your insurance premiums. If you do those things, we're going to jack it up. With the idea being, we are going to try to influence your behavior because you probably want to save money. We're going to, you will do some things that are better for your safety. They will cause less outflows from the insurance company, and everybody will probably be better off. But they're trying to influence their customers' behavior. There's some also with the credit score thing where if you invest your money wisely and don't run up a lot of debt, you can get some better rates that way. So I think this influence behavior is another interesting case where you can help make your clients, your customers, more sustainable in what they're doing. So the question really boils down to, where are you on your AI or AIoT journey? If you're pretty early on, maybe you're needing some education. Maybe just some basic, what is AI? How do I think about it correctly? Maybe there's some specialized topics you want to pursue. We can help with that. Maybe you're a little bit farther along and you've got some specific issues for your business and you want to focus on those. That will take a little bit more time to understand what really is going on in your business. But we can do some workshops there to help you understand that and to make some good roadmaps and understand how best to pursue your goals in that situation. And if you're fairly advanced, then maybe you actually want to build some ML models. You want some proof of concepts. Maybe you want to push them all to production. We can help with that as well. So if you'd like some help with that, give us a call. We'd love to talk with you and to keep our world and make our world more sustainable. And that's it, Jason.
Sorry, it takes a second for me to disconnect that.